If you look at the code needed to interact with the hardware, it looks something like this. And admittedly, it looks cryptic, overwhelming, and really complex. In fact, it's really not that bad. All it takes is some divide and conquer to understand the various pieces. And if you put the effort, in a week time, you will find everything written quite intuitive. Hard to believe, but let's do some divide and conquer here. One way to look at this is to look at the main pieces that make up this program. This is known as a class, and it starts with a class definition, and it gives it a name. It's called first because this is the very first program we're going to write. And forget about this part. It just tells it that you need to interact with an interface library, and it ends with end. Anything in between is really the body of that class. So far so good. What's inside that class? Think of the class as an entity or an agent that's going to monitor the hardware for us and produce some output when the logic dictates. One observation at this stage is that the name of the class is first, and the name of the file is actually first.m. These two are the same. So whenever you have a class of a given name, you can give it any name you want. It's very important that you name the file after the class name with the .m extension. Now, the class itself should be able to interact with the hardware. So if you think of it as an agent or a person even, all right, then it should have the two characteristics that we typically assign to entities or to agents. They must have some memory so that they would remember what's happening. This is known as the state of mind, if you like. And it must have some behavior, actions that it takes. Distinguish between these two. Memory is simply to remember. So if, for example, you counted how many times the pulse monitor detected a pulse every minute, then that would be a piece of memory. Action, on the other hand, would be something like listening to a particular digital input. Action would be something like producing a particular digital output. So whether the action is in response to some event, or if it's a voluntary event, they're both part of the behavior. So in terms of syntax, we notice that the memory section of the object, let's start calling it a software object. The memory section is sandwiched between properties and end. So properties is the keyword that tells MATLAB that we're about to write some memory-related statements, whereas methods here is the syntactical header that indicates that whatever we're about to write here should be part of the actions assigned to this object. Both sections must end with an end. Similarly, the class as a whole starts with a class definition at the top and it ends with an end. All right, so let's take a look at what could possibly appear in the memory section. Let's say we want to count how many, inputs are activated, something like that. So I have here count equals 0. Count is known as a variable because I'm using it to hold the number of pulses, let's say, or the number of inputs, and equal 0 is the initial value that I would like it to have. So initially, I haven't detected any inputs, so I set it to 0. There are other things here. For example, interface remembers the interface object that we have. timer callback delays because, we have some alarm clock and we want it to reactivate every 100 milliseconds or something. These are the kind of statements that you would put in the memory section. They are declarations of variables. You specify the name of the variable and optionally you give it an initial value. Typically, the property section is straightforward. Whenever you need a variable, you just declare it up there and initialize it if you need to. The action or the behavior is the interesting section here. This is where the actual logic or code appear. And we distinguish three kinds of actions. Some are constructor actions, some are main actions, and others are reaction or responses. What's the difference between them? The constructor actions are things that need to be done when this object is born, all right? These are usually system kind of initializations, and you really don't need to be concerned with them. All the programs, all the classes that we write will have the same constructor section in them. The main action is really what you like your agent or your object to do. All right. Do you like it, for example, to activate certain outputs? You want it to count certain thing? This is where you assert the procedural part of your code. Reactions, on the other hand, are simply responses to inputs coming through the hardware or coming through any other mean. So in reaction, it's like our responses to our sensors as humans, for example. When a particular muscle notices, feels something, you normally have some reaction to it, and that would be here. All right? So just like before, each section appears separately, and usually it has a header at the top that indicates it and an end. So let's look at the constructor section in particular. As I said, this is the section you really need not be concerned about, but you need to know it exists and you need to know its syntax. It starts with the keyword function. Actually, all these actions start with the keyword function, and then it has a name for this particular object, and notice here that it has the same name as the class. In other words, we decided earlier that the name of the class and the name of the file should be the same. Now we're adding that also the name that you put here in the constructor section must also be the same. So why is that relevant to us? Well, suppose we want to copy this program and produce some other program. Instead of first, we want to call it second, all right? Then we can say save as, and we'll have a second, but then that will become second.m. But then manually, we have to change the name of the class to become second and the name of the constructor section to be second. Those three should always be the same. Aside from that, the constructor section is pre-written for us, and I'm not going to be concerned with it. The main action also starts with the keyword function, and it says main because it is the main part. And it has this designator, which we noticed here. This, if you like, is the name of our object, all right? I know it's called first, and outsider talk to us by talking to first, but internally within this object, we are known to ourselves as first, as this. So this, if you like, is the alias by which we call ourselves internally. So the main function has this coming to it as a parameter. The rest of the main function looks like this. The body of it. It says press enter to start. We have seen this in the guided tour, that this is how the procedure starts, and it ends by press enter to terminate. So these two statements simply allow the user to indicate when listening to the hardware should commence and when should it be terminated. In between the two, you can have statements that do things for you. And this is a kind of statement that we have used in the guided tour to activate digital output number 3, in other words, to set it to logical 1. So that's an example of a main. Now, in terms of the event listeners, or the reactions, if you like, or the responses to external events, they look something like this. There's the keyword function and an end at the end. And this particular listener listens to changes in the digital input, hence its name, DI change, digital input change. And it receives two parameters. It receives this, which is our internal name, and the event that occurred externally. And if you like to see, for example, what is it that it has a print statement that says, yes, we received a change in the digital input, this particular digital input, and it captures the change through the event object that was thrown to it. So if you like, whenever a digital input has changed, it creates an object and it passes this object to this particular function. The object is called event, and you can get the ID of that event. In other words, you can find which particular digital input was activated. So this entity here, this creature, is a number between 0 and 7. And this is the value, that the state, if you like, of that digital input. So it could be either 0 or 1, depending whether the digital input was deactivated or activated. Remember that the object of this program that we wrote is to count how many times digital input has changed. Any digital input and any change, we want to count all of them. Hence this statement, it says the count variable that we declared in our memory section. Remember, in the memory here, we set count to 0 initially. Now we refer to it. Notice that when you refer to it, you qualify it, you precede it by the name of the object, which is this, and a period. So this dot count refers to this particular count. So when we say this dot count equal its previous value plus 1, it means increments the count that you have. So initially, we set the count to 0 in our memory section. Suppose one of the digital input was grounded, hence it was activated. In that case, this function will wake up, and we execute the statement by saying, change the value of the count variable, take its previous value, which is 0 initially, and add 1 to it, so it makes it 1. So now the value is no longer 0, the value now is 1. If a further change occurred, for example, a second digital input got activated, or the same digital input became deactivated, we trap both of them, and we increment again. Now it becomes 1 plus 1, so the new value will become 2, and so on. So anytime you monitor this dot count, or you output this dot count, you will know how many times the input has changed.